Hi guys, let's see. Let's go ahead and solve this sum of cubes problem. You can tell because first of all there's two terms, and x cubed is a cubed. It's made up of x times x times x. 64 is made up of 4 times 4 times 4. Okay, and so sum of cubes, a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. That's how it factors. So first thing I'm going to do, I'm going to find what a is. I'm going to find what b is. A is x cubed, or the cube root of that. So that's just x. X times x times x is made up of, when you multiply them, it gives you x cubed. And then 4 times 4 times 4 gives you 64. You need to also find out what a squared is. So x squared, which is x squared. What b is, and that's 4 squared equals 16. You need to also find out what ab is, which is x times 4. That's a 4x. Okay, let's go ahead and drop it in. So x plus 4 and x squared plus 4, oh, I'm sorry, it's a minus 4x plus 16, and this equals 0. So we're going to split this up, and we have an x plus 4 equals 0, and an x squared minus 4x plus 16 equals 0. Let's solve the left side. So x equals -4. We have a b squared minus 4ac, and that's a -4 squared minus 4 times 1 times 16. 16 minus, so 4 times 16, and that's going to give you a -64. 16 minus 64 equals -48. When you find the sum or difference of squares and you do the quadratic, usually you will find that it's never factorable. You have to use the quadratic formula, okay? And so that's what it showed us here. So x equals 4 plus or minus the square root of -48 over 2a, so that's just 2. And so x equals 4 plus or minus, now we have an I for sure, and then 48 is 2, 24, 2, 12, 2, 6, and 2, and 3. So it's made up of a 2 times 2 times 2 times 2 times 3. So it's made up of 2. Well, if I put it back into the radical, it's 2 times 2 times 2 times 2 times 3. So here's a pair and here's a pair. So that's a 4 square root of 3 over 2. 4, 4, and 2 are all divisible by 2. So we have a 2 plus or minus 2i to the square root of 3. Okay, we have this, and we have x equals -4. Those are our two roots. Okay, and we're done. Good job, guys.